done in the class 8, speed, that means distance upon time. Whenever we consider the distance in a physics, you will always use the term rate. That means speed of the body. That means it is the rate of change of distance with time. How much distance it's going to cover in a particular time. So that's why if you write a definition, you will write down the term rate. That means the speed of body is the rate of change of distance with time. Speed, you know that speed is a scalar quantity. So we will not consider the direction over here. Suppose you are going to say that car is moving with a speed of 5 km per hour. That means you will not mention the direction over here in any direction. So it will remain the just 5 km per hour. So how it's changing with time? Changing with time, that means the rate of change of distance with time is known as the speed. What is the unit of speed? There are the two types of system, MKS system and the CGS system. In the MKS system, like this, so in the MKS system we will always consider that this is MKS system. MKS, that means distance in meter, mass that is in the kilogram, and the time in the second. And in the CGS system, the one more system, distance C, that means in the centimeter, mass gram, and the time will remain in the second. So if you write down the unit of speed, it will distance upon time. So in the MKS system, it will meter per second, or in the CGS system, it is the centimeter per second. And now the type of speed. First, it is the uniform speed. Uniform speed, that means it is going to cover the equal distance in the equal time interval. So obviously it is impossible in the crowded places. How can the bike or the car can cover the equal distance in the equal time interval? So practically it is not possible, but uniform speed means the equal distance in equal time interval. But non-uniform, or the other term is the variable speed. That means you are going to school. Obviously, whenever you go to school, always you will follow this non-uniform or the variable speed. That means it will cover the unequal. The speed may be varying. That means if it covers unequal distance in the equal interval of time, same time, in the 1 minute it can go for the half kilometer, or in the other minute it can go for the same 1 minute, it can go for the 2 kilometer. So in the time interval remains same, but it will cover the unequal distance. So practically we always follow this non-uniform or the variable speed at the crowded places. And unit, again the unit will remain same. For the distance it will remain meter per second, and for the MKS system, and in the for CGS system it will remain the centimeter per second. Now the different type of speed. Average speed. Average speed, that means total distance upon total time. That means you are going to school, you will cover the total distance upon total time. So that you can, by these value, total distance upon total time, you can calculate the average speed. Again the unit will remain same, and the MKS system it is meter per second, and in the CGS system it will be the centimeter per second. Now I am going to explain the different term, that is velocity. Velocity, difference between speed and velocity. Speed is a scalar quantity where there is no role for the direction, but the velocity is a vector quantity. When the velocity is a vector quantity, and I have already explained the distance and displacement. Distance is a scalar quantity and the displacement is a vector quantity. So when you consider the velocity, the thing will remain same. Again, it is the rate of change of displacement with time. So in the place of distance, now we are using the term displacement, because velocity is a vector quantity. So you cannot use the term distance over here. We'll use the term vector quantity, that is the substitute of the distance in the term of vector quantity. It is the displacement. So in the case of velocity, your formula will hold velocity is equal to displacement upon the time. That means the rate of change of, again the time, that means you will use the term rate, the rate of change of displacement with time. Unit, velocity and speed are the same. In the speed you will not consider direction, in the velocity you will consider the direction, because it's a vector quantity and the speed is a scalar quantity. In the MKS unit, the MKS system, the unit is the meter per second, unit will remain same, and in the CGS system it is the centimeters per second. Again, what do you understand by the uniform velocity? same if it covers the equal distance in the equal time interval. So it's practically it is not possible. Now come to the different term, that is the non-uniform or the variable velocity. Non-uniform or the variable velocity, that means many things can happen. First, non-uniform, that means the magnitude is changing. Second thing, magnitude maybe remain same but change in the direction, or some other possibilities, both the magnitude and the direction can change. Try to understand this. Suppose a thing that is moving in a circular path, like in this direction. Suppose in this thing, it is the direction, in this point direction is this, in this point direction is this, in this point the direction is this, in this point direction is this. That means in this uniform circular motion, the speed is the constant. You can say here is the speed is v, here is the v. But what is going to change? That is the direction is changing. Here is the direction is v, there is the direction is up, here is the direction towards this, and this direction is downward. That means the uniform circular motion where the speed is the constant. Speed is the constant, but that means the value of speed is the same. But because the direction is the changing, so that way we will consider the velocity. Velocity, that means the speed is the constant. But because the direction is changing and velocity is a vector quantity, and we will always consider the direction over here. So this uniform circular motion is an example. This will come in your exam, where the speed is the constant, magnitude is the constant, but your direction is variable. That's why you can say it is an ideal example of speed constant, because the magnitude is the constant, but the direction is changing. Direction is changing, and in the velocity we will consider the direction. So velocity will be variable. So uniform circular motion is an ideal example where the speed will remain constant, but the velocity will remain variable. So in this way, the non-uniform or the variable velocity may be change in the magnitude, change in the direction. Here you can see that only the value will remain same, but the direction is changing. But in some other example I will give it to you, where the magnitude and the direction both can change.